Boom. Got it. Very good. Hey, what's that? I may. This would have probably been a little easier to help you with had you been here on time as well. Here you go. All right. Hey, so guys, let me sort of lay out for you a little bit about what we're doing today so that you have a sense of the bigger picture. And I think probably the easiest way to do this is, rather than starting here, why don't we jump over to our calendar and make sure that we sort of have a sense of how we're moving forward. So guys, what we're going to do today is we're actually going to take the second step in a journey that we already began. I know that you probably, if nothing else, you noticed that only half this page was complete. The reason that only half this page is complete is because there are some important ideas that we're going to talk about today that are going to allow you to finish this. But guys, understand this is also a bigger part, a smaller part of a bigger journey that we're taking in terms of getting you settled in lab. So guys, if you join me at the calendar, I think this is going to make sense. So guys, today what we're going to do is we're going to finish the conversation that we started on Thursday. We're going to wrap up this activity, and then what you're going to see is when you're done, it sounds weird, but when you're done with that activity, you will actually bring it to me and trade me for your homework. So the homework will actually reflect the stuff that you're finishing in the activity. But the way this is going to go then is, this is fast. It's going to be like 15 minutes of new material. Then we'll wrap up that activity. You'll trade me. I'll review it with you and then keep it if it's good. Turning back to you your homework then. But guys, here's the scoop. The homework that you have today will not be due on Wednesday. I know that you haven't quite fallen into this groove yet. But guys, typically when we do homework, like for example today, when we do homework, it would normally be due the next class period. That will not be the case with this assignment. You'll notice that it says that the reporting is due on the 28th. The idea is we are not going to have time on Wednesday to review this homework. So guys, Wednesday you won't have homework. You'll just come in. Wednesday, the very first thing we're going to do is we are going to reshuffle our seating chart based upon these papers that you gave me. We're going to reorganize a little bit. And then guys, we're going to do lab safety, get over into lab, and actually break you up into your lab groups and get you settled in your drawers. So that'll be on Wednesday. And then guys, Friday when we come back, we will actually then review that homework, and you will submit your homework scores by midnight Friday night. Then guys, coming back, on Friday, we're going to go over some ideas about how to work in lab. And then when we come back after the weekend, we'll actually be over in lab completing our first lab that we're going to do for the year. So again, guys, today, short day, important day. You'll wrap up the activity. You'll trade me for homework. You'll then have time in class to finish up that homework. But again, it won't be due until Friday. Y'all get the idea? Okay. So guys, grab your note-taking materials and we're going to get started. Here we go. So I need to get rid of this, and I need to grab this, and I need to do this. So guys, the date today is the 24th. And the topic for your notes today is representing accuracy. So across the top of your notes, I would strongly encourage you to title your notes. Again, the date is the 24th. And guys, remember, one of the things that you were to have done was to have brought a 3-ring binder with 5 dividers. And assuming that you followed through on that, guys, that first divider is actually class notes. So as you're working through this, when you're done, you can put this in your class notes collection so that you have that stuff at your fingertips as you're thinking about either doing homework or getting ready for the test. All right. So you guys all settled? You ready to go? All right. Then we're going to dig in. So guys, grab that sheet that you've got in front of you. Not your homework sheet or not your note sheet, but actually your lab sheet, the activity sheet. And guys, as you're looking at this, what I'd like you to do, if you would please, is turn your attention to numbers 8, 9, and 10. Now guys, before we dig into this important idea, let me make sure you understand what we're doing here. So last time in class, we talked about the idea that when we collect quantitative data, we want to collect data that is appropriately accurate. And guys, based on that idea, you started circling. Allow your eye to scan down your page, and you'll notice that you were circling numbers in your measurements. So guys, let's pause for a second and remind ourselves what was important about why was it you chose to circle some of these, what made those digits circleable? Which digits were we circling? Go ahead. Beautiful, guessing, estimating, right? And guys, that's exactly the idea. Some of these digits that we were measuring are digits that we were not confident of. So remember the rule. When we make a measurement against a scale, we estimate 1 decimal place past the accuracy of the scale. And guys, those digits we circled. Now guys, here's the deal. You will never circle these digits ever again in this class. That is actually not the way we handle estimated digits. We're going to talk today about how we actually handle them. So guys, again, turn your attention to 8, 9, and 10. So this is the thing that you measured the length of in 8, 9, and 10. If you didn't call it a graduated cylinder, don't change it. But guys, here's the question. In number 8, you only measured the length of that cylinder to the ones place. And then in number 9, and guys, check your answers. In number 9, you should have measured out to the tenths place. And then in number 10, you should have measured out to the hundredths place. The question is, why are they different? Why is it that these measurements don't all have the same number of places? Do you remember? Why don't they all have the same number of places? Because if you don't know the answer to this question, there's an important idea here that you're missing right now. Why is it? Go ahead. Okay, good. So, and I like the way you said that our measurements are becoming more and more accurate. But here's the question. What allowed these measurements to become more and more accurate? Do you remember? Do you remember how you made them? Because this was actually the device that you made these measurements with. And if you remember, when you made measurement number 8, this was the side of the stick that you were to have used. So this thing measures in tens, so you estimated to the ones. Then guys, the next time you did this, you used this side of the stick. So in number 9, this thing measures to the ones, so you estimated to the tenths. And then in number 10, you used this side of the stick, and this side measures to tenths, so you estimated to hundredths. Is that starting to come back to you? Guys, that's the key to what we're talking about today. The idea is that we need to understand how to talk about these digits that represent accuracy. Now guys, here it's pretty straightforward. This is accurate to the ones, this is accurate to the tenths, and this is accurate to the hundredths. The thing that makes this a little bit trickier is when we have to deal with zeros. And guys, this is where you're going to want to start writing things down. So grab something you can write with, not exactly here, but just watch. So guys, this is our transitioning thought. We understand that numbers represent measurements, and measurements have accuracy. And accuracy is based upon the quality of the device that we use to make the measurement. So we need to learn to communicate accuracy. So guys, here, again, it's pretty straightforward. Accurate to ones, accurate to tenths, accurate to hundredths. But guys, here's the important question. What do we do with zeros? Don't try to draw this, but just watch. So guys, we're going to sort of do something like I did last time when I did this for you as a demonstration. And we're going to make some measurements. But now we need to talk about the importance of zeros when we make measurements. And it goes like this. So guys, we have 3 different scales. These yellow bars are all exactly the same length because I just copied and pasted them. But guys, notice like last time, we now have the exact same scales that we had here. So this one measures to tens, this one measures to ones, and this one measures to tenths. Here's what I want you to do in your notes. And guys, please, you've got to commit to this. In your notes, label, like across that top line, put A, B, and C. A is on top, B is in the middle, and C is on the bottom. And guys, here's what I want you to do. I want you to measure, I want you to make measurements and write down what you would write down on A top, B middle, and C bottom. What would you write down if these were the measurements that you were making? Please commit to these, guys, because understand, I know that this just sort of seems like this is weird, this is rulers, this is abstract. But guys, understand the concepts that are lying beneath this activity are going to be something that's going to become very important to you throughout this year. So we need to get this driven home. So guys, let's take a swing at this. Starting at the top, letter A. The idea is that this thing measures in tens, so we will estimate to the ones place. So Isaac, what did you put as your measurement for number 1? So let's think about this. So as we look at this thing, 9 would probably lay down here, right? And maybe it's tough from a distance, sorry. 9 would probably lay down there. So if 9 is there, and as we look at this thing, I think we can say with some certainty that it's past 9, and it's even all the way up to 10. Are you comfortable with that idea? But now the tricky bit is, what about the ones? So guys, if we say that this thing is 10 centimeters long, you're like, wait, I thought I was supposed to measure to the ones. Well, the idea here is that we did, and there just weren't any ones. So are we okay with this idea that this would be 10 centimeters? Okay, so now let's go down to the next one. And guys, as we look down at this next one, we now have a scale that measures in ones. So if it measures in ones, we'll estimate to tenths. So Ryan, what did you put for letter B, the middle one? 10.0. Okay, so and I did as well. I would say 10.0, the idea being that we're comfortable with it being 10, we're looking for tenths, and we just didn't find any. Are we okay with that idea? Okay, so Atticus, help me with the last one. This last one is also 10, but now we're measuring to tenths, so we'll estimate to hundredths. So what did you say for the bottom one? So help me with 2 zeros. After the decimal? Beautiful. And I would agree. So in this case, we would go 10.00 because we looked at tenths, we estimated to hundredths and didn't find any. Now guys, here's the trick, and this is important. Don't miss this idea. Which one of these numbers is bigger? Top, middle, or bottom? Which one's bigger? Which one of these numbers is larger? Do you see that they're all the same? But here's the question then. Guys, top, middle, or bottom, I want you to vote. Which one of these numbers is better? Bottom's better? Top is better? Why do you think top is better? Let me say that differently. Let me use a word that's better than better. That was weird. How about most accurate? Yeah. Okay, and I should have been more clear. So guys, what about this then? Top, middle, or bottom? Which one's more accurate? The bottom one? How do we know? Say it again, Tori. Keep going. What? Good. Good for you. Yeah, and so Atticus said 2 zeros. And as we go into those additional zeros, these zeros communicate accuracy. And guys, that's the thing that makes this tricky. When we look at measurements that include digits, you're like, okay, I know how accurate that is because I understand those digits were measured or estimated. But guys, when we have zeros, it gets a little bit weirder. So what we need is we need a way to be able to examine these numbers and say, this is more accurate than this is more accurate than this, based only upon the numbers that we're given. And guys, that's what we're going to talk about today. You're going to write down 4 things, then we're going to practice, then we're going to finish that activity, then you're going to get your homework done today. So guys, the entire conversation that we're having today is all about how do we communicate accuracy. This is where you want to start writing down notes. These are rules that you should jot down. So guys, when we talk about communicating accuracy, what we really need to know is how do we deal with zeros. So guys, these are the rules. All of these numbers are what are called significant digits. Significant digits are digits that communicate accuracy. Again, guys, you want this in your notes. So significant digits, again, are digits that communicate accuracy. And guys, what you're going to find out is that there are 4 types of significant digits. But here's the deal. Never on the test will you see a question that says, what are the significant digit rules? You need to be able to apply them. You don't have to memorize them. But guys, the rules go like this. So here are the rules for significant digits. And again, I would encourage you to scratch them down. So the question is, what digits communicate accuracy? Here are the rules to figure this out. Rule number 1 is this. Non-zeros always communicate accuracy. 1 through 9. If it's not a 0, it communicates accuracy. So guys, let me show you what I'm talking about. This is what you need to be able to do. Bless you. So you see a measurement that says, and you don't write down the examples. So you see a measurement that says 96 grams. How many digits of accuracy does that give? 2. The 9 and the 6. That's all you've got to be able to do. So the 9 and the 6 are both accurate. They're both significant. So guys, what about this? Show me fingers. How many significant digits in 61.4? I got a vote for 3. A couple votes for 3. Are we all in agreement with 3? It's 3. But now guys, watch this. What about 0.52? 2 or 3? And the answer is we don't know. Because we don't know what to do with the 0. Guys, the 5 and the 2 are both accurate. But is the 0 accurate? And that's where we need to go next. So guys, rule number 1 says if it's not a 0, it's accurate. But the rest of the rules, of which there are 3, are all about the zeros. So guys, here comes rule number 2. Final zeros after the decimal place are accurate. So guys, the question then becomes this. What on earth does that mean? What does it mean to be a final 0 after the decimal? So let me define these for you. So guys, final means at the end. After the decimal means to the right of the decimal place. So guys, let me show you some examples of this. Let me zoom in so that you can see these. So let me show you some examples. So for example, the number 10. How many significant digits in the number 10? Well, the number 1 is significant. It's accurate. What about the 0? Does it pass the sniff test? Is it at the end of the number? Absolutely. But is it to the right of the decimal? It's not. So guys, that 0 is not significant, and that would only be 1. So guys, what about this now? So is the 1 significant? You bet. How about that 0? That 0 is also significant because it is a final 0 after the decimal. It's final, meaning it's at the end. After the decimal, of course, means that it's to the right. Hey, why don't you just do this? But now, guys, this brings up an interesting question. What about the 0 in between? Is that 0 significant? That guy that's in between the 1 and the 0 to the right, is it significant? And guys, in order to answer that question, we actually need the third rule. So guys, the third rule is this. Trapped zeros are significant. So guys, let's go back and let's take a look at this example. So now the idea is this. We have 1.0 We know that this 1 is significant, and we know that that 0 is significant. The 1 is significant because it's not a 0. That 0 is significant because it's a final 0 after the decimal. But now, guys, you can see that that middle 0 is trapped between the other two, and that gives us 3 significant digits. Is that okay? Let me show you one more example, and then we're going to play with this, and then we're going to be very, very close to done. So, guys, another example of that, would be something like this, where we have a number like 8.00035. So, are those zeros significant? Yeah, they are, because they're trapped between the 8 and the 3. You'll notice, guys, there is a decimal in the mix there, but the decimal doesn't matter. So that would be all of those. All 6 of those digits would communicate accuracy. They're all significant. You guys okay? Let's do one more thing, and then we'll move into this and see how we're going to apply this. So, guys, rule number 4. And rule number 4 is really, really simple. Nothing else counts. So, guys, that's it. The big idea for the day today is we need to figure out what digits communicate accuracy. And it's really straightforward. If it's not a 0, it communicates accuracy. If it's a final 0 after the decimal, it communicates accuracy. And then if it's a trapped 0, it communicates accuracy. And guys, rule number 4 we don't even need. It simply says nothing else communicates accuracy. So, guys, that's the big idea for the day today. So, let's see how we're doing. So, guys, if you're interested, there's actually a university that put together a little tutorial that'll allow you to fiddle around with this and see whether or not you really have a sense of it. The link is in the notes. Feel free to access it. But, guys, we're going to allow this to sort of be our review. Making sure we're good with this. Then we're going to do one more thing, and then we're going to get you guys to work. So, guys, it goes like this. So it's really, frankly, a pretty darn simple website. You click on new number, a number comes up. You type in the number of significant digits that you think are represented, and then down at the bottom it just tells you if you're right or wrong. So, guys, let's see what this thing cooks up. You guys will vote with fingers, and let's see how we're doing. So again, how many digits of accuracy are in these numbers? So, guys, we need to talk about this really quickly. This is a number in scientific notation. The E is actually times 10 in calculator speak. So if you look at that number, it's actually 2.4 times 10 to the negative third. So when you figure out the number of significant digits in a number in scientific notation, you just look there. Don't worry about the exponent. It's just the 2 and the 4. So that would be 2 significant digits. All right, so with that said, let's see what this thing comes up with. We'll look at some examples, and then we'll wrap up with one more idea. Here we go. All right, so how about that? How many significant digits in that number? What do you got? I'm seeing some 2s, I'm seeing some 3s. So guys, let's go through the logic of this and let's check. So we know that the 3 and the 1 are significant because those are not zeros. So now let's look at that 0. Is it a final 0 after the decimal? Which one does it fail, the final or the after? It fails the final. Guys, it's not at the end of the number. To be a final 0 after the decimal, it would have to be over here. So it is not a final 0 after the decimal point. And then is it trapped? Well, no, because there's nothing to trap it. So guys, that is not a significant 0. It doesn't tell you accuracy. All it does is make the number smaller. So this would actually be 2 significant digits in that number. So let's look at some others. Guys, what about this dude? Is that 0 significant? Yes or no? How do you know? Why? Because it's trapped. Good. All right, how about that 0? Significant? Yeah, it's trapped. How about that 0? Significant? Why? Yep, final 0 after the decimal. How about those? Both of them. They're both final zeros after the decimal. That guy? Final 0 after the... Those guys are. Those guys are. Those guys are. Those guys are. That doesn't have any. That guy is... How many in that one? 2. Both of the 1s. Again, 2. How about that guy? All 5. Those are significant. Oh, what about that one? Is that 0 significant? Because it's trapped. Guys, that's all there is to this. Final zeros after the decimal, trap zeros, that's all you need to know. Please. No, they are. So, and forgive me, I skipped through those so quickly. The idea is if there's no zeros there, all the other digits are significant because 1 through 9, they always count. Is that okay? So it's just the zeros we would need to think, because all the other ones always count. They're always measured, so they're always accurate. Is that okay? You guys good? Okay. Guys, there's one more thing we need to do with this. If you're feeling good about identifying significant digits, then guys, the only other thing we need to do today is figure out how to use them functionally. And this is what we're talking about. Guys, across your page, please write these down. The number 314721, and then in parentheses, please write the number 4. And then moving over a bit, the number 0.001775, and then in parentheses, please write down the word or number 2. And then guys, on the far right-hand side, 8092, and then please write down the number 2. So, guys, this is what you've actually got to be able to do with these to have a functional understanding of significant digits. It's good to be able to count them, and it seems like most of you are feeling comfortable with that. But, guys, the tricky bit is you also need to be able to round to them. So, guys, here's what I need you to do first, just to make sure you're where you need to be. Above each of these 3 numbers, so above this, above that, please write down how many significant digits are in each of these numbers. Just write it up above. Then, guys, what we're going to do in just a second is we are going to go through and we're actually going to round these numbers to the number of significant digits that are requested in parentheses. But let's do first things first. So, guys, starting on the left, we're going to talk about this first guy here. So, looking at this guy, so Claire, how many significant digits are in that number on the left? Good for you. And do you see how they're just all significant if they're not measured? So that would be 6 significant digits. So now, guys, let's move to the middle. So, Josh, that number that's in the middle, we know the 1, the 7, and the 7, and the 5 are, right? How about those zeros there? Do they count? No. How come? You're right. Why don't they? Say it again. Yeah, so they're not at the end of the number, so they don't count. So those dudes aren't significant. And guys, let me just tell you right now, that 0 will never be significant. It's not even necessary. I put it there just to locate the decimal point. So therefore, that would be 4 significant digits. So Tori, you do the last one. How many significant digits in that last one? Why is that 0 significant? Beautiful. All right. So, guys, let's call time out for a second and make sure we're all caught up to that. We've got 6 and 4 and 4. Does that feel okay? Okay. So now, guys, what we've got to be able to do is round these numbers. So do this with me because you're going to need this practice. So, guys, this is 6 significant digits, but what we're going to do is we're going to round it to 4. Now, you can probably do this in your mind's eye, but I want to write it down just so you see. So, guys, to do this, what we're going to do is we are going to count 4 significant digits. So we are going to round to that 4th significant digit, which is the 10th place. So if we're going to round to the 10th place, we look at the next decimal, and it's a 2. So does it round up or does it round down? It rounds down. So guys, write this down with me then. It's 314.7. Now, guys, here's the question. What happens to the 2 and the 1? And we talked about this earlier, the very first day of class, but now let's explain why. Guys, when we round numbers below the decimal, we do not replace them with zeros. We get rid of them. Do you now see why? What happens if we put these zeros on? How many significant digits is that? All of them. It's 6 again. Guys, that's why we do not replace the digits below the decimal with zeros, because when we do, they become significant zeros again. So when we round numbers that are below the decimal, we cut off the zeros, and that would be rounded to 4 significant digits. So guys, let's do another one. We're now going to round this one to 4 significant digits. So now we need to count significant digits, and it goes, oh no, I'm sorry, we're going to round it to 2. So we're going to go 1, and we're going to go 2. Now, guys, we look at the next decimal. That's a 7, so that rounds up. So to round that to 2 significant digits, we have 0.0018, and that would be rounded to 2 significant digits. Questions there? Okay, guys, this last one's a little bit tricky. Do this one with me. There's something interesting going on here. So guys, we're going to round this to 2 significant digits. So we go 1 and we go 2. Now guys, what about this? Well, the 9 rounds up, right? So if the 9 rounds up, we end up with 81. And that's 2 significant digits. But guys, why don't we just leave it like that? What do we do with the 9 and the 2? We replace those with zeros. Are those zeros significant? No, they're not final zeros after the decimal. But guys, they are important because if we get rid of those zeros, then we turn 8100 into 81, and we're radically changing the value of the number. So numbers below the decimal, you cut them off. Numbers above the decimal, you replace with zeros. So guys, that's the scoop for today. So again, the idea is that as we continue this journey, we're figuring out how to represent accuracy. We learned last time in class that we estimate 1 decimal place past the accuracy of the device. Now we know that those digits all collected together communicate accuracy. But there are some rules about figuring out how accurate these numbers are. And now we've learned to apply these rules, not only by figuring out how many significant digits the numbers contain, but also now we know how to round them, which allows us to do some calculations that we'll be doing later in the year. So guys, that's it for today. Any questions or things here? This is functionally what you've got to be able to do. You guys okay? Okay, so here then is what we're going to do. I'm just going to steal yours, Josh. So guys, if you would, please grab this assignment that we started last time. And you'll notice that in the last column that you completed, you've got a string of measurements. Then guys, the next 2 columns are what we're doing now. So the next column over simply says, identify the number of significant digits in your measurements. Please do that. Then you'll notice the next column over from there says, now round your measurement to 1 fewer significant digits. So if it had 4, round it to 3, 3 round it to 2, and so on. So guys, this is your immediate task, is to get this sheet done. When you're done with that, please bring it to me. And what I'm going to do is I will go over it, just scanning it, making sure there are no glaring mistakes. And then guys, when you're done with that, I will actually then give you your homework for today, and you'll be working on this as well. So, let me do this really quickly. So guys, as you're sort of getting started on this, let me explain to you how this homework assignment works. This is actually what it looks like. I know that you're working diligently, but let me do this for a second just to make sure there's no confusion. So guys, this is your homework assignment for today. This is what this thing looks like. And up here at the top, what you're going to do is you're just going to count significant digits. So this one's got 2, this one's got 6, this one's got 5, and so on. Then guys, down here, what you're going to do is you're going to round these numbers to the number of significant digits in parentheses. So this one will go here, this one will go here, this one will go there. So it's saying take 71 and round it to one significant digit. So that would become 70 and so on. So they go from the top down to the bottom, and you'll round them down at the bottom. So guys, finish up this activity. When you're done, bring it to me. I'll trade you. And then guys, remember, this homework is not due until Friday. Wednesday, we're going to get settled over in lab and get to work over there. Come on up.